This video covers basic file handling for the CIE 9618 Computer Science A-Level. This is 10.3 in the spec. You'll need to be able to explain why we need files, understand the limits of variables and RAM, and why programs must persist data beyond runtime, i.e. why we need to keep data after our programs have finished. You need to be able to write pseudocode to handle basic text files. And I've also included some information on reading files into arrays and then writing them back from arrays, as this is a really common thing we need to do. So why are files needed? We want data that have been processed by our program to outlast the execution. We want it to persist afterwards. Variables and arrays, things like that, they only exist in RAM while the program's running, and when it ends it's all lost. So if we can store files on secondary storage, they persist, because secondary storage is permanent storage, it's non-volatile. Also, RAM is limited. Sometimes we get datasets that are far larger than our available memory. So with files, we can work on a much larger dataset without being limited by the amount of RAM we have. And also, data needs to be moved around sometimes. We want to share files between programs and transfer it from one computer to another. We might need to come back to it later in another program to read it as input to process it again. So text files are simple file structures where we have a line of text, a line of characters, followed by another line, followed by another line, and so on. So at the end of each line of text, there is usually special characters which move it down onto the next line. And programs process the text file sequentially, i.e. one line at a time, starting at the very first at the top of the file, and they work all the way through normally to the end of the file. Every file like this has an end of file marker, which is a Boolean flag that indicates whether or not the end of the file has been reached. And you can check this by using the end of file function. So if you say EOF and the file name, this will return true or false, depending on whether the file is at the end or not, i.e. the last record has been read, the last line of the file has been read or not. And a file must be opened before you can use it, and it should be closed once you've finished. So here are the pseudocode commands you'll need for handling files. First of all, you need to open the file with open file, and then you give the file name. That could be a variable name or a literal string containing the name of the file. And then you say how you want to open the file. So you can either open it for read, if you're just reading through the data, open it for write, if you want to create new data, and append if you want to add the new data onto the end of an existing file. Then read file is used to get the information from the file. Read file followed by the name of the file, then a comma, and then a variable that's going to store the value of the text and characters in that single line. So it will read one line into the variable that you provide. Conversely, the write file will take a line that you have created in the variable name or value. You can have a literal value or variable name there, and write it to that file. So you say write file, the name of the file, again either a variable name or a literal string, comma, and then the variable or literal string that you want to write to the file. And then you have the EOF function, so you can test to see if it's the end of file or not. You just say EOF brackets and the name of the file, again just a variable or a literal string. And then close file closes the file, releases it, and sometimes in some systems you'll find that if you haven't closed the file, not everything would have been written out to the file. So there's a buffer that doesn't get written to the file. So you have to close the file. And the syntax is just close the file, say close file, and then the name of the file. Again, just the variable name or the literal string is fine. So here's an example in pseudocode. we're reading a text file and we're going to read it line by line. In this example, we declare my file as a variable name to hold the name of the file. It's not strictly necessary to do that. You can just use the literal string directly, but if you're going to reference the file many times, it's often better to put it in a variable once and then just the variable name. You can make the variable name shorter, especially if you were specifying a file name with a path. That could be a very long literal string that you'd have to put in every time. So it's good practice to put that in a variable once at the beginning. Then we open the file. So open file, my file for read. And so we're just opening the file in read mode, which means we'll start at the top of the file. We'll be looking at the first line if there is any line there at all. If there isn't anything in the file when we open it for read, then it will set the end of file flag straight away. And that's why we're using a while not EOF there, because if it's empty, then we're not going to try and read it. If it's not empty, we'll go in there, read the file, read one line of the file into a variable called line of text, and then just output it. So that'll loop round. If we read, when we do a read file, if we do hit the end of the file, i.e. that we've already read the last one, that flag's true. We come round and the while not EOF no longer works, so we're going to stop the loop. And then finally we close the file, so just say close file, my file. So writing to a text file, very similar. Again, we're just declaring my file as a variable to hold the literal name of the file. We open the file this time for write instead of for read. And we're setting some variable values. So in this case, we're setting a name variable to a value we want, like Amara and so on. And we're writing with write file. So we just say write file, the name of the file, comma, and the variable where we're getting the data from, which in this case is name. And then we close the file. Note that if the file already existed when we open it for write, the contents will be overwritten, so any previous contents will be lost. If you want to add to the end of a file, we should open it for append instead of for write. So something that's commonly done is reading a file into an array. Here's an example of that in pseudocode. So again, we just declare my file to hold the name of the file, line to contain lines of the file, and scores is going to be the array in which we put each line of the file. And count is used as an index to the array locations. So we initialize my file to the name of the file, we set count to 0, and we open the file for read. And so long as the file's not empty, we're going to start reading the file. We read a line. We increment count to begin with from 0 to 1 because we've declared an array that's one indexed array starting at 1. So the first element of that array is going to have an index of 1. And in that we put the line we got. But remember that when you read text files, we're reading text and it treats it as a string. So we need to convert this using the int function if we want to convert that into a number. So we convert the line, the value we just read from the file, to an integer, and then store that in the array at location that is indicated by the count variable. So we'll go around and read each line into the array, and once we get to the end of the file, we'll stop and close the file. Now it's important to make sure that the array has enough elements to store all the lines of a file, and CIE in exams will normally tell you exactly how many lines there are going to be, or say there's an exact limit, so you'll know, you don't have to guess how many elements to put in your array. So writing an array out to a file is also very common. What we normally do is read a file into an array, process it somehow, and then write it back to a file. So for example, we might read it in, to an array, sort the array, and then write the sorted array back into the file. So same sort of thing here, we're opening a file for write this time. We've declared an array with 5 elements in it, each one is a string, and we're just going through the file. This time, because we know how many elements there are exactly, we're using a for loop instead of a condition controlled loop, so we're using this count controlled loop. And then we're saying for indexes 1 to 5, write to the my file, and what we write each time is the names array element indicated by the current index value. So the first time it writes names 1 and then names 2 and so on. So once they're all written to the file, we close the file. So just a few tips and reminders for things to avoid. We want to make sure that we test the end file before we read file. So each time we read file, we don't want to go onto a new read file if we've already reached the end of the file. That will cause problems in your code. Don't forget to close file. Almost always there's a mark point in the exam questions for closing the file. So there's marks for opening, reading correctly and so on, but typically you'll see a mark for closing the file as well. So that's an easy mark to lose if you forget to close the file. And wrong mode in open file. So remember that if you open it for write, you'll be erasing everything once you start writing to the file. If you want to add to the end, open it for append instead of for write. And remember, don't assume that the data is numeric. Even if it looks like it's described as numbers and numeric data in the file, because it's a text file, it is actually stored as text and therefore strings. So you've got to convert it if you want to make it. So integer numbers, you would use int, or real numbers, you use real. Okay, that's the end of 10.3, and the next section, 10.4, we look at abstract data types.